Hi everyone. Today I want to look at a fun sort of type level programming puzzle, actually that I worked on some years ago, but I think it'll be fun to share here. And that is about the function zipWith. So Haskell has a whole variety of zipWiths. So if I import data.list down here, we can see that we have zipWith. Whoops, if I spell it correctly. And it has this nice type, right? It allows us to take two lists, a list of A's and a list of B's, and combine them with some combining function of type A to B to C. So we can take corresponding elements from the first list and the second list, combine them to produce elements from the third list. Well, what if we have more than two lists? Well, we could do zipWith 3. So the sort of the basic zipWith is actually zipWith 2. If we did zipWith 1, it would be called map. So zipWith 3 here allows us to combine 3 lists, and we have zipWith 4, which allows us to combine 4 lists, and we have zipWith 5, which allows us to combine 5 lists. So this is all very well and good, but why do we have to write the number? Maybe type inference can figure it out for us. So today's video is an exploration of how we can do that. So we're going to see how I would build up that solution. The first step is thinking about the fact that, well, the way that this is really going to happen is by analyzing this component here, right? So I want to look at the first argument to my function. So let's let the final function I'm going to have is going to be called zipWith. So we're going to do but zipWith is in the prelude. So let's hide that. So import prelude hiding zipWith. Okay, so far so good. And I want to be able to write a zipWith at the bottom of my file here that, well, it's going to take in some function type f and then return some stuff. But the first step is going to be to figure out this f. So what I want to do is I want to have some way of analyzing that f and figure out how many arguments it has. That's going to control sort of the arity of my zipWith. So I can do that using a closed type family. So let me write it, and then I will explain it a little bit. Actually, let me give it a type signature first. So count args here is going to take the function type and produce the number of arguments it has. So that's a natural number nat. So we're going to have type family count args f, where count args, and let's see, if it's a function, arg going to result, then I want 1 plus the number of arguments in the result, right? And that's because, right, these functions, when I see something like this, right, this right arrow is right associative. So really, that's the same as if I had these parentheses like this. So when I'm counting the number of arguments, I just sort of peel off the first one, and then I'm going to add that to the number of arguments in the result. If we have something other than a function, then we're just going to say that that has 0 arguments. Okay, let's see how are we doing so far. Oh, there's already trouble. So I've written a standalone kind signature for my type family, just like I would write a type signature for a normal function. But that requires an extension, of course. So we have standalone kind signatures. Oh, and then now type isn't imported, so we import data.kind. And now nat isn't imported, so we import ghc.typelet. And then now to use a number like 0 at the type level, we need data kinds. Oh, and now we need type operators. Okay, how are we doing? Okay, illegal type family declaration. Okay, we need type families. Now what? Oh, now we need undecidable instances. Right, because GHC can't be sure that this will terminate. It will, but GHC is not quite clever enough to know that. And then we need to spell it correctly, evidently. Okay, good. So now we have this count args. Let's test it, right? When we write a function in Haskell, we like to test it right away. So GHCI has a not very well-known feature of kind exclamation point. So if I write kind exclamation point here, then I can run it on something. So if I say count args of int to bool to double, we get 2. Excellent. That's exactly what we want. Just to check, if I see kind args of int, or kind exclamation point of int, then forgot to call it count args. Kind of count args, if I spell it correctly, int, we get 0. Excellent. Okay, so we have this count args function, and it works. So now, we're going to have some function f here, and we want to infer that from the usage side. So I really just do want this to be f. I don't want this to be a count argsy thing. And then now the next thing, well, now we need a whole bunch of lists. So we're going to have lists from f, right? So now we need to take f and sort of break it down into its component pieces. And we're going to have to take lists from f and then result from f. So actually, I probably should have written this out first, because will I need count arg? I think I actually will in the end, but let's maybe not. So lists from f, this is going to be another one of these type families. So type lists from, and this takes the type of the function, and well, here this is already disappointing because I actually want this to be many lists, right? So this is not quite right. I actually want this to just be lists from f, right? Because we want some examples will be helpful here. So lists from, let's see, A to B to C. That should really equal A to B to C. Lists from A to B to C to D has to be list of A to list of B to list of C to list of D. Okay, so writing these examples, I see what to do here. And this is actually going to be a function from type to type. So type family lists from, and let's see. So lists from is going to have very similar structure to count args. So if I see arg arrow res, well, that's going to be a list of arg to lists from res. And then lists from other is just going to be the list of other, right? And that should give me my lists from behavior that I see at the bottom of the file. Let's see, does that work? So we can test that with kind exclamation point. So lists from int to bool to double. Ah, exactly. That's just what I wanted. Okay, so lists from is working. So now, let's see. So zipWith now has the right type here. And let's just say it's undefined for now, and just sort of see, does this inference work at all? So if I say, what is the type of zipWith of, oh, I need some fun functions, don't I? So let me write some fun functions. So let's gonna have fun1, which is int to bool to double, and I really don't care what it does. But now I'm curious, what is the type of zipWith fun1? Oh, can I do this in GHCI? Presumably. Ambiguous occurrence, data.list. Oh, I don't want to import data.list. How do I kill that? Let me try that. Okay. Let's see. tzipWith fun1. Aha! Look at that. That's good. Now, is it the right thing here? So car to bool to string to int. Let's see. So it's zipWith, same zipWith. I'm not writing zipWith 3 or anything like that. Fun2. Aha, that's exactly the right type, right? This list of cars is really list of string, of course. Okay, so that is excellent. Now, how are we going to actually define this thing? So we have to bind f over here. But now it's really going to depend, to be able to sort of know what the next thing is, I really have to know how many functions there are in f. So the only real way to do that is through a GADT, right? I need to take a GADT, a general algebraic data type. I need to take some type and then do some pattern matching on it so my type system can learn more about what's going on here. Let's see, how do we do that? I need to just think for a moment here. I know I'm going to need a GADT because I need to decide sort of how many parts there are in lists from f to know what my lambda should be. Because there's going to have to be some lambda over here based on it, and then I'm going to have to do something that's recursive and then call zipWith again. So it's going to depend on what this is. Maybe what I really need is I need a GADT to sort of witness the structure of F. So maybe this lists from is part of the puzzle, but not the entire puzzle. So, so I'm going to call this lists from witness. And this is also going to have type. And this is going to be a data type. And it's called witness because this is sort of runtime evidence for the particular nature of lists from. So here, let's see, we're going to have lists from other. Well, let's see, lists from fun. And this has to tell me lists from witness A arrow B. Is that right? This doesn't look right, but let's just go with it. Okay, so here, let me just keep my naming consistent. Okay, so first off, does that compile? Oh, multiple direct declarations of lists from witness. Really? Oh, this should be type, not data. Okay, so of course I need another extension. Defined but not used, F. Well, that's fine. Just say that, can't I? Oh, now it's very unhappy with that because it doesn't know that it's a function. Okay, so if we have this lists from, well, I'm going to need to be able to get an actual lists from witness. So what that means is now not only do I need this data type, but I'm going to need a class so that I can implicitly pass one of these into zipWith. So let's do type lists from class, which is going to have type arrow constraint, and then lists from class F, where witness is lists from witness of F. Okay, that compiles so far. So now here in zipWith, what I can do is if I bring F into scope using scoped type variables, right? So with scoped type variables, that means that when I say for all F here in a type signature, it means I can refer back to F in the body of the function. So I'm going to call this fun now so that we don't have two things named F, which is awfully confusing. So here, zipWith fun, let's see. Now I want to take a look at this, this witness. So case witness at F of lists from nil, and then we're going to end up with something, and lists from fun, and we're going to end up with something. Let's see, does that compile? Oh, I need type applications. Of course I do. Let me come back. I need to explain that, don't I? Okay, so now there's a no instance thing. For all F, and let me just put this in lists from class F. Okay, defined but not used. Fun. Once again, good, excellent. So what I'm doing here, the little at F, is taking witness, right? The full type of witness. I can't really write it this way in Haskell, the way that the class system works, but its real full type is this. And indeed, down here, if I ask for the full type of witness, that's what we'll see. Oh, I need to set print explicit for alls. And then we see its full type. So I've done this funny plus V here. Plus V means, GHC, don't try to come up with a cleverer type to show me. Show me the actual real type of the thing. I can't remember whether it's been implemented, but we're gonna slightly tweak the behavior of :t soon, so that we don't have to write this plus V to get more honest behavior out of it. In any case, so we see here that this witness has this type that is quantified over F. The specific F that I want to use is this one. So at F allows me to take this type variable here, F, and replace it with this type variable, F. Maybe it's a little confusing because they're both named F. But it's doing that. So then now I can actually pattern match on this and then make runtime decisions based on what I get. So if, in fact, we have lists from nil here, In this case, well, what do I have to do? This means that this function isn't really a function at all. And if it's not a function at all, right, let's look at what lists from would do. So kind, if I say lists from int, well, let's see, that should just return a list of ints. Well, what list of ints? It's going to turn out that the right thing to do is to say repeat fun. We'll see why in a little bit. But that should hopefully work. But let's see what happens. Couldn't match expected type lists from f with actual type list of f. So the problem here now is that we have a disconnect. So here I know that this, where is it? Because of the way that, I will know in the end, we'll see, I still haven't set this up yet, that this other isn't really a function, right? So here, lists from nil, it just says other. It doesn't say it must not be a function. There's no way of saying it must not be a function. So what I want to say here is actually, I want to tell GHC what the behavior of lists from is going to be in this case. So I can do that with an equality constraint. So we can say lists from other equals list of other, right? And by putting this extra little constraint here, it means that I now know when I pattern match on lists from nil, I know what I'm going to get out. I don't need to do this for lists from fun because GHC can see here that if this is arg or res, we're going to be able to compute lists from based on that. I think we're not going to need that. Okay, so now we're good because I've encoded this little piece here. And so down here, when I get lists from nil, I know that this lists from is just going to be a list containing that. Okay, let's look at the other case. So now here, I can use this type whole feature to see what do I need to write here. Well, let's see. Found whole of type list of arg from lists from res. So that means I get to write a lambda here. So this is going to be the first list. Excellent. So we're going to say that this is list one, and now what do I need to write? Well, now I need to do sort of lists from res. So that's intriguing because now I can call zipWith, because zipWith will in fact produce a lists from. So what I need to do is I need to take this this list one, and let's see, I have a function, and what do I want to do? I want to do zipWith of, let me think here. I think what I want to do is I want to apply this list. I want to combine that with whatever is coming next. But how do I do that? So here now, I'm going to have a whole bunch more lists. All right, I'm in a case here where need to return, right, lists from res, as we see in the error message. But how do I do that? I think, right, so what is it that I want to return? Let me just think for a moment here. This doesn't make for very good viewing, I know, but I need to think. Oh, I see. By the way, I edited out quite a bit of thinking there. This wasn't as easy as it looked. So what I need to do here is I'm going to need to call, I know I need to produce a lists from res. So happily, zipWith can produce such a thing. But I need to pass in a function. Well, what's the function going to be? Well, it has to be this function partially applied to this list one. And then it's going to end up to be this a function that does that partial application. Oh, but that's not quite right because I can't do that. I can't pass in a list, right? So this list one is going to have many different functions, many different values. And so if I partially apply fun to the list, I end up with a list of functions, not just a single function. So maybe my recursive structure of zipWith is wrong. And that's sort of where this repeat fun, because as I said, I did this years ago, so it's a little rusty in my head. But I think that this zipWith fun thing is going to be a little bit wrong in that I need to call a helper function go repeat fun. Aha, this is feeling good. So now go here is not going to take just a single function, but it's going to take a list of the functions f and then return lists from f. This seems more exciting. So now, well, actually, let me not get rid of all that stuff. So a lot of this stuff is good. So go funds, and I still need this case witness of, because I still need to handle two different cases. Now, the lists from nil case is easy. It's just funds. And then here, let's just see, does this still compile? Yes, good. Now I see where I can go, because I can call go, and I can take, what I want to do is I now have a list of functions and a list of arguments, and I want to apply each corresponding function to each corresponding argument. Well, how do I do that? That's just with zipWith. But now it's the old zipWith 2. So I'm going to call go, and I need to pass in a list of functions. Well, what's that list of functions? It's going to be prelude.zipWith. Or actually, I'll just write it out here so we can see it. So it'll be go zipWith 2 funds list 1. And I'm hoping that will work. So where zipWith 2, I'll make it a local thing here. zipWith 2 is just going to have, is our old friend zipWith. Oh, well, hold on. No, it's not. I could zipWith $2, but let me not do that. I'll just call this apply. And here we have apply, which is going to be a list of A arrow B to a list of A, and it's going to produce a list of B. So let's see, apply of F's, X, X's is going to be Fx cons apply F's, X's. And then in any other case that means that lists have unequal length, we just return the empty list. Okay, what do we think of this, GHC? A curs check cannot construct the infinite type res equals arg arrow res. Well, why is that happening? I don't know why that's happening, but let's try to figure it out. In the first argument of apply, namely funds. Well, let's see. Funds in this list from fun case is really A arrow B. This looks okay to me. Why is this trouble? Why is this trouble? It's acting as if it can't do polymorphic recursion. So let's sort of write everything out, shall we? So lists from fun. Oh, I don't have the name for this thing. Blarg. Let's see. If list 1 has type, this is going to have type list of A for some A, and then apply here. Whoops, for all A, B. Apply here is going to be specialized at A. Let's see, is it happy with that? It still cannot construct the infinite type. Go fun. Why is it? Hold on, let's see. Expected type, arg arrow F, but the actual type is F. It says that this is a list of F, but why does it want, so actual type is list of F. I agree with that, but we should know relevant bindings include, but it doesn't have any, it doesn't tell me what we've gotten from lists from fun, but lists from fun should tell us that we have something of this shape. And then accordingly, we should also know that this has the same type. So what I need to do is I need to be able to extract out the arg and the res from lists from witness here. So this is really annoying, and we I suppose it's implemented in head or something, but I'm not running on head right now. So instead, I'm going to have to add proxy arguments here. This is very annoying, so that I can extract out the type so that I can get better type errors. Very, very annoying. So here, list from fun is now going to have to take, this is going to be arg, and this is going to be res. And so now this list one, this should really be a list of arg. And if it's not, then that's something very strange. And apply here should really be a function from arg to res. So now, oh, we don't have proxy. That's very silly. Of course we don't. Import data.proxy. Now couldn't match proxy res with arg arrow res. Actual type proxy res. Now something is very strange. Go actual type in the first argument of go. So this is the result of apply. What on earth is going on here? Something very strange. Apply should take 2 arguments and return a list. Apply is very simple. What is going on here? Couldn't match to expected type list of f. So go expects a list of f. So that's good. I agree with that. But not any f. I can be even more specific. Go, if I make go, well, no. I was right. I muttered earlier, it looks like it's not doing polymorphic recursion. What did I mean? I mean that this f is fixed to be this f out here. But of course, recursive calls to go don't use that f. It uses another f. So I'm just going to call this local f. Right? Because this is going to change at every recurrence. So now, not in scope. Well, okay, no, I suppose it's not. So let's bring it into scope. Okay. So now let's see here. Oh, we're still getting weird things. Cannot construct the infinite type arg equals proxy arg. Expect the type lists from local f. Actual type proxy arg. There should be no proxies here. Why am I getting proxies? Why am I getting proxies? This makes no sense at all. Is there another error? Sometimes you look for another error to make more sense of things. So expected type proxy arg to proxy res. I don't expect that type. Do you? I expect the type. So funds apply here says that I'm specializing it to arg and res. Oh, phooey. Maybe you all saw that. I forgot to write the proxy here, and so of course it's completely thrown off. And then now, good. Okay, this is much more sensible. Could not deduce. I like could not deduce. That one I can deal with. Okay, let me clean up that mess. That was an awful distraction, but it gets you to see that even I run into trouble. So let's take all of this stuff away. We don't need it. GHC can infer all of this. I was just doing that to get better type error messages, and then I made things worse instead of better. Okay, so now we have could not deduce because when we did not know that local f is in this lists from class. So let's just fix that. Lists from class local f so that I can get a witness of type local f. That makes sense. And then in my recursive call, I still don't know lists from class. That's easy enough. When I get lists from fun, I just need to be able to say lists from class of res here, so that way when I get lists from fun, I get the information that I need. Aha, this compiles. Hooray. Now let's try to call it. So we have example 1. Well, example 1 should be a list of double, because example 1 is going to be zipWith of fun1, 1, 2, 3, true, false. Let's say true, false, true, so that they're equal length, although we should test it without equal lengths. No instance for lists from class here, right? Because I'm calling zipWith, we need to have this lists from class. So how are we going to get that? That I expected. Okay, we're back on the train. So here I've made this class, but I haven't written any instances. The instances are fairly easy. So we're going to say instance lists from class for a function, arg arrow res, where the witness is just lists from fun. Let's see, how do we like that? No, we're probably not going to like that. No instance for lists from class res. Well, haha. We can just add a little constraint here. And, well, we still have no instance for lists from class double. So what we need now is we need the base case. So we can do lists from class other, where witness equals lists from nil. Illegal instance declaration. That's easy to fix. Flexible instances. Okay. Couldn't match type lists from other with list of other. So the problem here is that, of course, this other, that might it turn out be a function. And so if it's a function, then we're gonna be in trouble again, because this list from nil really only works for things that aren't functions. So this list from class isn't quite going to work. So I maybe could do overlapping instances, but my guess is that still wouldn't work, because GHC isn't clever enough to sort of connect overlapping instances with the way that type families work. So this isn't quite good enough. We need a little bit more strength. So instead what we need is this lists from class. Instead of just taking one argument, it needs to take 2, where the second argument is the actual number of arguments. So lists from class F is going to also have n. We might have to do, let's see, if we have a functional dependency, F it implies n, which it really will, because the function will give us the name. This n is really just to control instance selection. So now we have lists from class here, and this is going to be some number n, where this is n minus 1. Well, I can already tell you we're going to run into trouble, because minus doesn't really work all that well for natural numbers. So instead of using the built-in natural numbers, I'm going to want to have my own version of natural numbers. So we're going to do data nat equals 0 or suck nat. We're going to get rid of typelets here. And then we're just going to replace this with suck and this with 0. Okay, now I'm in all kinds of trouble. So here, this is now n, and this is going to be suck n. So now I can pattern match on this suck n to know that I want this instance. And then down here, this one is only going to be for 0. Let's see, how are we doing now? Not a function kind. Up here, it's now typed to nat to constraint. Okay, expecting one more argument to lists from class. So here at all usage sites, really what I want is, I'm going to use LFC, and this is just going to take the function, and this is going to be lists from class F, count args F. I knew I was going to need that at some point. And then now I just change this to be LFC, and I'm sure I'm going to get a whole bunch of other errors. Use flexible contexts. Okay, I can do that. And then let's see, a legal constraint synonym. Well, I can fix that with constraint kinds. And then, it wants multi-param type classes, but I know it's going to want functional dependencies next. So we'll jump to the chase there, and because that implies multi-param. Okay. Functional dependencies conflict between instance declarations. So it does. Okay, so maybe I don't actually want functional dependencies, right? Because GHC, again, it looks like this other could be a function, and then these conflict. So let's get rid of that and see if that causes too much trouble. Could not deduce. Okay, so maybe this list from witness also needs to be quantified over the nat. So we have here like this. Let's see. Is it happy with that? Oh, now it's expecting one more argument, but this can just be this LFC thing. And now what? Now, could not match type lists from other with list of other. Well, it really should be able to do this because I know the number of arguments is 0 in this case. So, but I still need to memorialize that somewhere. So I'm going to have to say here lists from other is list of other here when I choose the instance. Now it's expecting, oh, this needs to go down to this LFC synonym. And then lots and lots of stuff. Okay, could not deduce this arising from lists from fun. Oh, count args res. Aha. We need to connect the argument here. So we need count args of res to equal n here. Right, because that's what needed. Let me just undo that and replay that a little bit for everyone. So here, could not deduce lists from class res count args res. So lists from fun here, to use the lists from fun constructor, we needed to satisfy this LFC constraint. And to satisfy this constraint, right, so LFC expands out to this list from class F, count args F. So it's critical that here, that for this LFC to hold, that this N needs to be the result of calling count args on res. Otherwise, we're not going to be able to satisfy lists from class F count args F. We're just going to have lists from class res N for some N. There's no connection. And so by adding this extra little equality constraint here that's saying count args res equals n, that now we can make that connection and get the error to go away. Okay, let's see what's next. Okay, so now we're down here. Could not deduce lists from class local f n0. Oh, because we don't know what n0 is, it looks like. Let's see here. Arising from a use of witness. Could not deduce. Aha. Is it ambiguous? No, it's not ambiguous. Oh, but it is a little bit ambiguous. It's ambiguous here because I said witness, but I haven't said what the n should be. So I really want this to be at count args of local f to fix it. So this was sort of my attempt earlier at the functional dependency was to avoid having to write this little bit here, but that's not so bad. Now that compiles. Wait, the whole thing? Is that it? Are we done? Example 1 compiled? Does it have the right contents? Well, it has the right length. That's a good step. Let's maybe have a more interesting function here. X true equals, let's say, x plus 3.14, fun1, x false is from integer of x plus 2.78. Oh, from, it's not an integer, is it? That's very silly of me. From integral. Okay, so now, example 1, we get some stuff. The stuff is right. Excellent. So that is really, really good. Okay, now what about example 2? Example 2, this has to be a list of int. Oh, by the way, I don't need that. I don't need these type signatures. So let me comment them out. We should be able to infer them. Equals zipWith fun2 of ABC and true, false, true, and hello, goodbye, hi. Okay. Let's see, does that compile? It does. Do we have the right type? Example 2 has type list of int, and the contents, well, it has the right length, but let's do something more interesting here. So C, B, and S. Let's just take the length of show C plus show B plus show S. That's an int. And here, if I look at example 2, we get 14. So that's, let's see, this is going to have 3 characters when shown because it's tick a tick. So it's 3 plus 4 is 7 plus 5. This is shown. So it's actually 7 because we get those. So that's 14. And then here 3 plus 5 is 8 plus, what is that, 9. 8 plus 9 is 17. And then here we get the correct answer. So look at that. It actually works. So it's quite a lot of technology to go into this. But at use sites, it's really quite simple. We just write zipWith and it infers the type. My hope would be that the optimizer would be clever enough to optimize a lot of this stuff away, but I'd have to analyze that in a little bit more detail to know for sure. But in any case, we can we could test that and try to work on that. Maybe that would be the subject of a future video. So let's just recap a little bit here. It all started from the fact that I wanted to be able to inspect this type F in the type of zipWith, right? And that led me down that we needed this lists from idea. But then to be able to propagate the information, we needed quite a bit more technology. In particular, we needed a witness type that sort of remembers what we've learned from our closed type family, right? If we look at the closed type family and we look at our witness type, there's a parallel here. There's 2 equations in the type family, and there's 2 equations here in the witness type. Yes, there's these extra constraints. As we sort of saw that they needed to arise to just continue to propagate that information down. We also needed a class here so that I didn't have to manually build up this witness at call sites. I want to be able to infer the witness from call sites, and using a type class allows us to do that. Then there was a fair amount of following type errors and connecting the dots, including a little bit of a dead end along the way. But again, it just shows you that even when you've been doing this for quite a while like I have, you do get stuck sometimes. Anyway, I hope this has been interesting. The code for this example is posted up on GitHub, and thanks for watching. Bye.